So for week number 8, lesson number 2 and 3, graphing a system of linear equations in two variables and categorizing when a given system of linear equations in two variables has graphs that are parallel, intersecting, or coinciding. Remember that the graph of a linear equation ax plus by equals c is a line. And every point of the line or on the line is a solution of the equation. And every solution of this equation is a point on this line. So we have three kinds of linear system. First is consistent and independent, with one number of solutions and the geometric interpretation of the graph of the lines are intersecting. Second kind of linear system is the consistent and dependent, with infinitely many solutions and its geometric interpretation, the graph of the lines, are coinciding lines. And the last one is inconsistent, with none or no solutions, with the graph of the lines are parallel lines. So let's do the practice. We will be using our lesson week number 6, lesson number 1 as a recall. So based on our lesson here, we actually graph different linear equations into variables, and there are different ways to graph it. So let's have the first way, wherein the general form is converted to slope-intercept form. So let's take this example. We need to graph the following system of linear equations and describe each pair of lines and tell the number of solutions. So we have two linear equations in two variables. So let's start first with equation 1. X minus y equals negative 4. So this standard form will be converted into slope-intercept form, which is y equals mx plus b. So we will be having negative y on the left side, and by addition property of equality, we add negative x on both sides. So we have this negative y equals negative x minus 4. Then by division property of equality, we can divide both sides by negative 1 to come up with y equals x plus 4. So you do always remember the different steps on converting standard form into slope-intercept form. So here we can now identify the slope, wherein the m, which is the m, and the y-intercept, which is the b. So your slope here is positive 1 and y-intercept is positive 4. We can now graph the equation y equals x plus 4 by using the slope and its y-intercept. So on our previous lessons, we need to plot first the y-intercept, which is positive 4. That is located along y-axis. And using the slope, the ratio of rise and run, we have 1 unit rise and 1 unit run. Since the slope is positive, it rises from left to the right. So we have the 2 points connecting to one another. This will be the graph of the equation y equals x plus 4. Next is we need to do the same thing with the equation number 2. So 2x plus y equals 1. It will have y equals negative 2x plus 1. We actually add both sides by negative 2x, so we can get y equals negative 2x plus 1. From here, we can identify the slope, which is negative 2, and y-intercept is positive 1. So same thing or same process that we do on the first equation, we need to plot first the y-intercept on our Cartesian plane. So there is the y-intercept positive 1, and using the ratio of rise and run, we have 2 units rise and 1 unit run. And since the slope is negative, the graph of the line actually is decreasing. So this is the second point. Connecting the 2 points, it will look like this. So as you see, the 2 lines actually intersect one another, and there is actually a point of intersection. Okay? So the point of intersection there has coordinates of -1, +3. That would be the solution. So as a recall, the point of intersection on the first example is -1, +3. It means this is the solution of the system of the linear equations given. And this is the kind of consistent and independent equations with only one solution, and the graph of the lines are intersecting. So again, the system is consistent and independent. The graphs of the equations are intersecting lines, and it has only one solution. For example number 2, graph the following system of linear equations, describe each pair of lines and tell the number of solutions. Okay? So again, let's start with the first equation. -2x plus 5y equals -15. Convert it to y equals mx plus b. The equation will be y equals 2/5 x minus 3. So from here, we can identify the slope, which is 2/5, and y-intercept, which is -3. So we can now graph the equation. So again, start with the y-intercept, -3, and count the number of rise and number of run using the slope. So the second point will be there, connecting to one another. This is the graph of the first equation. Now for the second equation, -4x plus 10y equals 10. The slope-intercept form of this equation is y equals 2/5 x plus 1. So our slope here is 2/5 and y-intercept is +1. So we need to graph it on same Cartesian plane. Start with the y-intercept +1 and count 2 units rise and 5 units run. So we have the second point connecting to each other. This will be the graph of the equation number 2. Then as you observe, the 2 lines are parallel. So it means the kind of linear system that possesses example number 2 is inconsistent, wherein there is no solution, no point of intersection. So remember, if the system is inconsistent, the graphs of the equations are parallel lines, and it has no solution. And as you observe, the slopes are equal. Third example, graph the following system of linear equations. Describe each pair of lines and tell the number of solutions. So we start with equation 1. -2x plus 3y equals -9. Transform it into y equals mx plus b. We have y equals 2/3 x minus 3. And the slope here is 2/3 and y-intercept is -3. So graphing to our Cartesian plane, the y-intercept is -3 and we need to count 2 units rise and 3 units run. This is the second point connecting to one another. This is the graph. So let's proceed to equation number 2. So same process. This standard form of linear equation will be transformed into slope-intercept form. Okay. So we divide everything by 6, negative 6. So our equation here is y equals 2/3 x minus 3. And as you observe, they are just the same. So if we need to graph it, it will be look like this. It actually overlapped to one another. So it means that the kind of linear system here is consistent and dependent with the number infinitely number of solution. Okay, so the lines coincide. So remember, the system is consistent and dependent. The graphs of the equations are coinciding lines, and it has infinitely many solutions. So for example, number 4, graph the following system of linear equations with these two pair. First is 2x plus y equals negative 8, and the slope-intercept form of this is y equals negative 2x minus 8. And our slope here is negative 2 and y-intercept is negative 8. So by graphing, we start with negative 8 and count 2 units rise and 1 unit run. Since the slope is negative, the line is decreasing. So the second point will be located here, and connecting to one another, the graph of the line will be look like this. For the second equation, so same process, x minus y equals negative 1. The slope-intercept form of this is y equals x plus 1. And our slope here is positive 1 and y-intercept is also positive 1. Graphing to our Cartesian plane, start with positive 1 as the y-intercept and the slope is positive 1, 2. So connecting to one another, that will be the graph of the line. And as you observe, the two lines intersect one another and there is a point of intersection. There. So the coordinates of the point of intersection is negative 3, negative 2. So it only means it has one solution, and that would be consistent and independent kind of linear system. So remember, the system is consistent and independent. The graph of the equations are intersecting lines and it has one solution. And as you observe, the slope and the y-intercepts are different to one another.